Alright students, I am going to discuss the question number 2 which has appeared in the JEE Advanced 2015. That is, question number 2 says, if x comma y are skew symmetric matrices and ZB, okay, the order I have not written. This one is of order 3 cross 3 and Z is also of order 3 cross 3 symmetric matrix. Then out of these 4 matrices which are given, then then which of the following is oblique R skew symmetric? The 4 options are given: A, y to the power 3 z to the power 4 minus z to the power 4 y to the power 3. B is x to the power 44 plus y to the power 23. Then C is x to the power 4 z to the power 3 minus z to the power 3 x to the power 4, and D is x to the power 3, I think it is 23, x to the power 23 plus y to the power 23. This problem was asked in JEE Advanced 2015. Okay, let us see the proof of this one. Before going into the proof of this, let me just explain you these two words, that is skew symmetric and symmetric matrices. In the previous problem I have already explained you the transpose of a matrix. Means if A transpose, it is actually representing like this, A transpose. Okay, let me just take an example. If A is equal to, say, 1, 2, 3, then 4, 5, 6, 7, 8, 9, be any matrix, then transpose of A transpose will be written, means this row will become the column 1, 2, 3 in the column form, this 4, 5, 6 in the column, second column it will become, and 7, 8, 9 will become the third column, 7, 8, 9. So I hope you can understand that what is the transpose of a matrix. Means A transpose over here written, this row will become column, this row will become second column, and this row will become third column. Okay, that is the concept of the transposing any matrix. Now let me discuss the symmetric and skew symmetric. If A transpose is equal to, again A we are getting, then this implies A is a symmetric matrix, and if A transpose is equal to minus A, means the negative of the matrix, then A is a skew symmetric matrix. Alright, so if this type of problem comes where you have to test whether a given matrix is a symmetric or a skew symmetric, you have to first find the transpose of that particular matrix. So let me start with the first one, that is A. So in the A we are given with y to the power 3 z to the power 4 minus z to the power 4 and then y to the power 3. Alright, we have to test whether this one is skew symmetric or symmetric matrix. So what we have to do is find out the transpose of this. Okay, so if we had to prove this particular matrix is a skew symmetric or symmetric, then let us take the transpose of this. Now when you are finding such expression, means where you have, say for example, a plus minus a plus b transpose, then it will be written as a transpose plus b transpose. This is a formula which you can see in the R.D. Sharma book. It is given very carefully, very nicely. Similarly, if a minus b you are given the difference of two matrices, then it will be written as a transpose minus b transpose. So you are finding over here the difference of this matrix and this matrix. Transpose of that we can write it as y to the power 3 z to the power 4 minus z to the power 4 y to the power 3 and transpose of this. I hope till this point it is clear to all of you. Now when we are finding that y to the power 3 z to the power 4, then we can write it as y 3 times, means they are matrix multiplied y with y 3 times, then again z 4 times and transpose of that minus this can be written z and this will be y and transpose of that. Okay, now when we come across this type of matrix, first let me take this one. If a b transpose is written, then the order of this a and b matrix multiplication will change and written as b transpose a transpose. Similarly, if there are three matrices A, B, C transpose, then order will change, means it will be C transpose, B transpose and A transpose. And if it is A, B, C, D transpose, will be written D transpose, C transpose, B transpose and then A transpose. I hope these all things are clear to all of you. So using this particular concept, all these concepts over here and over here, do you find we can write this whole thing starting with this z as z transpose this one, then this z will be written z transpose, this z will be written z transpose, this y will be written y transpose and then y transpose, minus coming to this we have to start from here, that is y transpose third one, and then 4 times z transpose and then z transpose. I hope till this point it is clear to all of you. Now we are given with x and y are skew symmetric, alright, and we have taken over here if A is a skew symmetric, then the A transpose is equal to minus A, and x and y both are skew symmetric given, so it means what? X to the power x transpose is equal to minus x and y transpose is also equal to minus y. So in this and z is given as in the question, it is given z is symmetric matrix, and symmetric matrix I have explained over here is A transpose is equal to capital A. There is no minus sign in front of this, means plus sign is there, plus A or even nothing is written over here. So what will happen, we can write z transpose is equal to z. So these all z transpose can be written z only 4 times, and y transpose will be written minus y into minus y into minus y, then this minus appears over here, y transpose will be written minus y minus y minus y, and z transpose 4 times can be written z. I hope you all have understood what I have written. Now what is happening is this will become z to the power 4, and this 3 will be multiplied and written as minus of y to the power 3. That minus I am writing in the front, y to the power 3, and then this also will become minus y to the power 3 and minus of this, and this minus will make this one as plus y to the power 3, and these all things can be written z to the power 4. So what we are getting is, if I take minus sign common, then it will become z to the power 4 y to the power 3 minus y to the power 3 z to the power 4. I think we need not to take the minus sign common. Actually this whole thing comes out to be, this can be written in the front, that is y cube z4 minus z4 y cube. Let me check whether this one is same as we have started from where, y to the power 3 z to the power 4. I think it is same, y to the power 3 z to the power 4, then z to the power 4 y cube, z to the power 4 y cube. So are you finding that y cube z4 minus z4 y cube transpose is coming same as y cube z4 minus z4 y cube. So this implies y cube z4 minus z4 y cube is not a, is in fact is a symmetric matrix. Not skew symmetric. In the question we had to find out of the 4 which one is the skew symmetric. So we are finding that this one is not skew symmetric. So option A will not be the correct answer. Let me take the B, option B. B was x to the power 44 plus y to the power 23. So let us take the transpose of this. So what will happen? Using the previous concept, A plus B transpose can be written x to the power 44 transpose plus y to the power 23 transpose. So what will happen? This x will be multiplied with x 44 times, and transpose plus y 23 times, and transpose of that. Okay, and then again we using that concept, A B C D transpose is equal to D transpose C transpose B transpose and then A transpose. We can write this thing as, you start from here, x to the x transpose how many times? 44 times, plus this was equal to what? Start from here, y transpose how many times? 23 times. Now we are given x and y both are skew symmetric, so we are finding it, this will be written as minus x and dot minus x, last one, 44 times, and in this one plus this will become minus y, how many times? 23 times. So finally minus minus sign is multiplied 44 times, even number of times. So this will become x 44 times, and over here 23 number of times minus sign appears. So can we write, in place of this plus we can write minus, and this becomes y into y into y, and this will be 23 times. So we are getting this part as x to the power 44 minus y to the power 23. So it is neither symmetric nor skew symmetric. We have started from x to the power 44 plus y to the power 23. This one is neither symmetric nor skew symmetric. Okay, let me check the option C. C was nothing but x to the power 4 z to the power 3 minus z to the power 3 and x to the power 4. So let us find the transpose of this and see whether it is coming this one same thing or negative of this whole thing. So once again we can write this A minus B transpose as A transpose minus B transpose. Now this can be written as x how many times? 4 times, and z cube can be written z 3 times, transpose minus z and then x and transpose of that. So again, using the property which we have discussed in the previous part, we have to start from here. Then this will become z to the power z transpose, and then x transpose, this x transpose, minus, coming to this particular part, we have to start from here, x transpose, this x transpose, then this one x transpose, then this x transpose, then this z transpose, then this z transpose, then this z transpose. Now it is given to us that Z is a symmetric matrix. So Z transpose will become Z, but X is given as a skew symmetric, so we can write X transpose as minus X, then minus X, then minus X. Coming to this part, these 4 will be written as minus X 4 times, minus X, and Z transpose 3 times, because Z is given as the symmetric matrix. So finally it is becoming Z to the power 3, and minus appears 4 number of times, so this will become x to the power 4 minus, now minus appears 4 number of times, so it will be plus x 4, and this will become z to the power 3. Let us check whether this quantity is same as this one or not. We are finding that z to the power 3 x to the power 4 is over here, and x to the power 4 z to the power 3 is over here. So in order to make this one same as this, don't you think we can take minus sign common? So x to the power 4 z to the power 3 minus z to the power 3 x to the power 4. So what we are finding, what conclusion we can draw is x to the power 4 z to the power 3 minus z to the power 3 x to the power 4 is a skew symmetric matrix. This is what we are looking for. So option C may be correct one over here. Option C is true. Let us check the fourth option also. The option D is given as x to the power 23 plus y to the power 23. So in order to test whether it is skew symmetric or symmetric, let us take the transpose of this whole thing. Then it will be written x to the power 23 transpose plus y to the power 23 transpose. So we are finding it is nothing but x into x into x. How many times? 23 times. And y to the power 23 is nothing but y into y into y 23 times. Whole power t, whole power t. Sorry, this one is this. So again, using the property, we have to start from here. X to the power t, x to the power t. How many times? It will come 23 times. Plus this can be written y to the power y transpose dot 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 y transpose. How many times? 23 times. Now x and y both are given as skew symmetric in the question. So in place of x transpose, all these x transpose, we can write minus x 23 times. Plus this can be written again minus y dot 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 minus y 23 times. So you are finding that minus sign appears 23 odd number of times, so it can be written minus x to the power 23 plus minus sign again appears 23 times, which is odd number of times, so it will be, in place of this I can write minus sign y to the power 23. So finally we can write minus of x to the power 23 plus y to the power 23. So we are finding that x to the power 23 plus y to the power 23 transpose is coming as minus x to the power 23 plus y to the power 23. So we can draw the conclusion that x to the power 23 plus y to the power 23 is a skew symmetric matrix. I hope you understand. You all have understood this. So it means D option is also true. So there are two options correct in this one, and they are, we have proved previously which one. D is proved and another one is, I think, C. This C is true and D is true. So out of these four options, this C is true and this D is true. That is your answer. Thank you.